Hi, welcome to Mrs. Park's Algebra 1 class. This is Chapter 7, Lesson 2, Dividing Monomials. So our previous section we did multiply monomials. So today we're going to move on to dividing monomials. Right, so why? Why would we do this? If we had a scenario where a tallest redwood tree is 112 feet, or about 10 to the second power meters tall, the average height of a woman in the United States is 1.62 meters. The closest power of 10 to 1.62 is 10 to the 0th power. So a woman is about 10 to the 0 power meters tall. The ratio of the tree's height to the woman's height is 10 to the second over 10 to the 0th power, or 10 to the second power. This means the tallest redwood tree is approximately 100 times as tall as the average woman. Fascinating. Alright, so when we are dividing, quotients and monomials, we can use the principles for reducing fractions to find quotients and monomials like 10 to the second power over 10 to the 0 power. In the following examples, look for a pattern in the exponents. So if you have 2 to the 7th over 2 to the 4th, there's 7 of these 2's, and there's 4 of these 2's at the bottom. Remember, when you're using fractions, top and bottom cancels out if you have the same one. Okay, so we canceled out 4 of them, and you have left 2 to the 3rd power. You have 3 of those 2's left, so 2 to the 3rd power. Same thing here when you come to t's, you have t to the 4th, t to the 3rd. There's 4 t's and 3 t's. Each one cancels each other out, and you're left with 1 t. So here, look at the pattern. 7, 4 becomes 3. 4, 3 becomes 1. So quotient of patterns. To divide two powers with the same base, subtract their exponents. For any non-zero number a and any integers m and p, so a to the n power over a to the p power, all you're going to do is a m minus p power. So you have c to the 11th over c to the 8th. You have simply do 11 minus 8, which you have c to the 3rd. R to the 5th over r to the 2nd. 5 minus 2 is r to the 3rd power. So when you're dividing, you're going to just subtract the exponents. Okay, so assume that no denominator equals 0, so simplify this. Alright, so you have g to the 3rd and g. Remember, when there's no number there, there's always an invisible 1. Okay, so 3 minus 1 is 2. And you have h, you have 5 minus 2, which is 3. Okay, so all you did was top minus small, bottom, top minus bottom. Okay, so here's your turn. Go ahead, do numbers 1a and 1b. You're just going to subtract the exponents and rewrite it as in simplified form. And come back when you're done. Alright, welcome back. We can use the product of powers rule to find the powers of quotients for the monomials. In the following example, look for a pattern in the exponents. So here you have 3 to the 4th, and they're in parentheses to the 3rd power. That means 3 times 3 times 3, 4 times 4 times 4. So you have these factors. Okay, that means 3 to the 3rd, 4 to the 3rd. C to the 2nd, D to the 2nd. So you're just applying the powers to within the parentheses. Okay, so A over B to the n power means you get the power out to the everything, including the top and bottom. So a to the n power over b to the n power. 3 to the 4th power, 5 to the 4th power. R to the 5th power, t to the 5th power. Alright, so this power applies to each top and bottom. So 3, I'm going to just redo it here. You can look over this, but we can also make it easier. 3 to the 2nd power is 9. 3 p cubed to the 2nd. So power to power makes it p to the 6th power. Excuse me. 7, you can't forget the 7. It also has the power 2. 7 to the 2nd power. 7 times 7 is 49. And there's your answer. So you're applying the power to both the numerator and the denominator. Okay, so your turn, 2a through 2d. Let's just do 1 together. Okay, let's do 2c together. You're going to do all 2a, b, c, and d. I'm going to just give you a freebie one here. But on your homework sheet, make sure you put all 4 of them. Okay, so 2 to the second y, 2 to the second, 2 times 2, 4, okay, over 3 to the second, 9, z cubed to the second, 3 times 2 is z to the 6. And that's all it is. You can't simplify anymore. If these numbers were not simplified, then you need to simplify 4 over 9, but 4 over 9 is already simplified. So there's your final answer. Go ahead and do 2a, 2b, and 2d. Make sure you write the answer for 2c as well, and then come back when you're done. All right. A calculator can be used to explore expressions with 0 as their exponent. There are 2 methods to explain why a calculator gives a value of 1 for 3 over 3 to the 0 power. All right, so if you have 3 to the 5th over 3 to the 5th, that means 5 minus 5, which is 0. So 3 to the 0 power, okay, so how does that work? So 3 times 3 times 3 times 3, and you have 5 3's here. They all cancel each other out. That means 1 over 1. Okay, just like if you have 3 over 3, that's actually 1, right? So everything cancels out to be 1. Since 3 over 5 over 3 over 5, 3 to the 5th over 3 to the 5th can only have one value, we can conclude that 3 to the 0th power equals 1. So that's going to be a rule now. If you have anything to the 0th power, it's 1. So 15 to the 0, 1. B over C to the 0th power, 1. 2 to the 7th 0th power, 1. Any number to the 0th power is going to be 1. Any number to the 0th power equals 1. Okay, so 0 exponent anything. It can be any term with letters or numbers. If you have to the 0th power, it equals 1. Okay, so here to the 0th power, this y to the 0, that's the only part that's going to be 1. Okay, so now you have x to the 5th power times 1, so you don't have to really write that. X to the 5th over x to the 3rd, 5 minus 3 will be x to the 2nd power, and I will be right back. Alright, so next is your turn, 3a and 3b. Go ahead and try that. Remember, when everything is to the 0 power, it's 1. But here you have d to the 0 power, so only that part is going to be 1. So you can simplify the rest. Write your answer and move on to 3b, and then come back when you're done. Alright, so negative exponents. So what happens when you have negative? Like 2 minus 5 is negative 3. So c to the negative 3, okay, so if you write this out, c to the 2nd power, c to the 5th power, there's 3 c's on the bottom. So when you write it, it's 1 over c to the 3rd. So when you have anything to the negative power, you're going to bring it down as a denominator. So c to the negative 3rd is actually equal to 1 over c to the 3rd power. Okay, so here we go. Anything you have a to the negative nth power, you can rewrite as 1 over a to the nth power. Okay, so 2 to the negative 4th is actually 1 over 2 to the 4th power, which is 1 over 16. So it goes backwards too. If you have a number that's a negative power, you can bring it back up as a whole number. Okay? Alright, study tip, negative signs. Be aware of where a negative sign is placed. So 5 to negative first power is 1 over 5, while negative 5 over 1 is not the same thing. This negative just applies to the 5. So the negative power is only when you can bring it down as a denominator. Alright, simplify each expression. Assume that no denominator equals 0. Okay, so what do we have here? N to the negative 5th. So this comes down as n. Okay, so I'm going to put it in fraction. N to the 5th power. Okay, I just brought down the denominator, made it positive. You have p to the fourth. Okay. You have a negative power here, so that can go up as r to the second power. Okay, and that's what we have here. So that's your final answer. Okay. All right. So this looks a lot complicated when you first look at it, but it really isn't. You're just gonna bring up or down depending if it's a negative exponent or not. Okay. So here, okay, I'm gonna look at just the numbers. 5 over negative 20. That can be rewritten as 1 over negative 4. So I'm not gonna write the 1, but I'm gonna definitely write the negative 4 in the bottom. Okay. So yes, there's an imaginary 1 here. If you want to write it for now, that's fine. Okay, so 1 over negative 4. That took care of that. Okay. And if you want to cross out as you're doing it, it's fine too. All right, here's R3, negative 3, R2. So remember, you're going to subtract. So negative 3 minus 2 is R to the negative 5th. Okay, let's keep it at that for now. T and T. 4T and 7T, T to the 7. So up here you have T. 4 minus 7 is negative 3. Okay, and you have here R negative 5th. All right, so I'm going to rewrite this. You have negative 4 in the bottom. You have R to the negative 5th. So that's going to go down here as R to the 5th. Okay, T to the negative 3rd is going to go down here, T to the 3rd. And this bottom one here, U to the negative 5th, is going to come back up here as U to the 5th. And that will be my final answer as shown here. Okay, so whenever you have negative, you're going to make it positive and flip it. And if it's up there, bring it downstairs. If it's downstairs, bring it upstairs. All right, that's a simple way to put it. So I know when you look at this, it's very overwhelming, but one step at a time. Just go through one thing at a time. All right, here's your turn. Oh no, one more. Not your turn yet. All right. So again, if you look at this, kind of complicated, but we'll just do one thing at a time. All right, 2 over 10. Okay, the 5 is going to go on the bottom, right? Okay, that cancels out a 1 over 5. I'm not going to put a 1. All right, so actually, let's redo this. Made a minor mistake here. All right, oops. Okay, let's start over again. All right, so here we had 2 over 10, which is 5 on the bottom, 1 over 5. I'm not going to put a 1 there. All right, you had a to the second minus negative 3, which became a to the 5th. All right, so done with the a's. B to the 3rd minus negative 1, which is b to the 4th. And then you have c here, which is c negative 5th plus minus negative 4, which will be plus 4. You have negative 1. So c to negative 1. All right, rearrange this. Anything positive will stay. Okay, and then negative will come back down as a positive. So c to the 1st, I don't need to put a 1 there. So a to the 5th, b to the 4th over 5c. Good? All right, here's your turn for A, 4b, 4c. All right, remember anything that has a negative exponent, you change and switch it. If it's upstairs, bring it downstairs. If it's downstairs, take it upstairs. All right, and that's the last slide for today. So make sure you pack your homework in your book bag. And thanks for watching.